So in this video we are going to fix the base relocations. So before let's quickly discuss about this base relocations. Suppose you have a program that contains some pointers. So let's say int a is equals to 10 and there is a pointer pointing to this address of this a variable. Let's say a value is at 2000 hexadecimal and also image base address is 5000 h. So that means this pointer will point to the address of this variable, that is from the base address to this 2000 h offset, that is 7000 h offset. Now whenever we run the program, this image base address may change because there may be some other module at this address. Then this image address is going to be changed for the entire executable, and then this pointer value become invalid. So let's say new image base address is 15000 h, and then this address becomes invalid. So what you need to do is you need to find the difference between the loaded new image base address and the preferred base address. So the preferred base address is 5000 and the newly loaded base address is 15000. So if we go and subtract this 1500 h and old preferred base address, that is you gonna get 10000 h. Now this value is called delta. So we are going to add this delta value to this address. So you will get 17000 h. So which is 2000 h offset from the base address, similar to the previous one. So this is the process we need to do for all the variables that are hard coded like this. So here if you go to optional header, if you go to this base relocation table, this address points to the first base relocation table. So if you go to this one is the first one. So this does not have any fixed size, but it has two members. So here you can see first 8 bytes. So first 4 bytes are page RVA. So this page RVA is offset to the page. So in that page we have some addresses and those need to be fixed. So the first 4 bytes are page RVA, and you can see it's 0 to 2000. So here it is this 22000 is page RVA, and the second member is size. So the size of this structure is the second member, that is 1A8 1A8. So that is the size, and these first 8 bytes are the two members, and the next members are the addresses, the offsets. The addresses need to be fixed. So the first 8 bytes are the page RVA and the size. So next 2 bytes is an offset from this page RVA. So the next 2 bytes are A000. So if you go ahead and add that, you will get the offset in this page, and the next 2 bytes and the next 2 bytes and the next 2 bytes and so on until you get the end or the entries. So we have this entries count. So how we are going to calculate the entries count is, so we have this the first base relocation size is 1A8, right? So 1A8 is the total structure size. So we can say 1A8 minus 8. So these 8 bytes are already occupied, and if I go and delete 8 from this, you will get the 1A0. So this from here onwards we have are the 2 byte values offsets up to 1A0. So 1A0 number of bytes, but each entry takes 2 bytes of space. So from this 1A0, to get number of entries, you need to divide this value with 2, and here we get the value D0. So that is what PUBare does, and parses into already parses and calculates. So we can just see and see and get the value. So first we are going to do is the calculating the entries count. So that is a very important thing. So let's go, and so we have nt header dot optional header dot base relocation table dot virtual address. So this when added to the base address gives us the pointer to this one. So I'm calling this first base pointer, and we are going to marshal this one, marshal dot pointer to structure and first base pointer, and marshal this as image base relocation. So let me call this as first base. So don't get confused with the first base pointer points to the starting address, and the first base is the structure. Now I can go and print this first base dot page rva dot toString, and here we can see the 22,001A8. So first we are going to count the entries, so we can remove this print. So first base dot size -8. This gives you the total number of offset size. So to get actual number of offsets, we need to divide with 2, because each offset takes 2 bytes. Now we can get the value in int entries count. So we can go and print this entries count. So if you print this, we get the value D0. So we need to loop over this. So how we are going to loop over this? We need to add the value of this size. So simply if you add the size of 1A8 to this base address, base pointer, you get the offset to the next one. So it's a very simple one. So what we are going to do is while first base dot size not is equals to 0, and we are going to add the to this pointer. So first base pointer, so first base pointer plus is equals to, we are going to add this one, first base dot size. So this is the entire size of the structure. And after that we need to marshal this one because after adding this size, it will be pointing to the next base relocation. So you can just copy this one. So now we'll be marshalling as the again first base. So you don't have to change these variable names. Now we can also put some entries count. So if you run this and we get D0E3A18, which is exactly what PEBER is showing us. So we got the entries count, right? So what we're going to do is then we are going to print these total offsets. So let's read this offset. So how you gonna read this offset is we know the number of entries, right? So this entries count defines the number of entries. So what we can do is we can loop over each entries and read these 2 bytes. So after reading these 2 bytes, we can add these 2 bytes to this page RVA to get the page offset. So 22000 plus A000. So let's first loop over this. For int I is equals to 0, I less than entries count I plus plus. So we are looping over all the entries, and one important thing we need to identify is the A. So here you can see the first these 4 bits are A, because if you go to PE file format in the Microsoft documentation, this is the base relocation types. So if it is 32-bit, we have the high and low value, but if it's 64, the first bit is first 4 bits are the A. So 10 means in hexadecimal A, so we need to first identify whether it is A or not. If it's A, then we need to do the difference of 64-bit difference. Sorry, 64-bit addition to that delta. So how you gonna read this? So we know that first base pointer plus 8. So this gives you the offset to the first entry, right? So first base pointer is this one. There are already 8 bytes, that is page RVA and the size. So if you skip these 8 bytes, you will get directly to the first offset RVA. So this is like a first one, and I need to add I into 2, because for each time we want to skip 2 bytes, because each offset RVA takes 2 bytes, and in the I in this for loop I value is like iteration, so we can just simply say I into 2. For the first iteration, 0 into 2, 0, which gives you only this value, which is of course offset pointer to this one. And if you I is equals to 1, you will get the 2, that is if you add 2 you will reach here, and 4, 6, 8, 10, etc. So in this way we can loop over this one. So I can say int pointer offset pointer. So we have this offset pointer, and we can use marshal dot read int 64, read in 16, because we are going to read only 2 bytes offset PTR. So let's call this as int offset RVA. So let's go and print this. So here we can see we got the FFF A000. So we got the exact same values as of this. So what we're going to do is offset RVA is equals to offset RVA. I'm going to do end operation with this FFFF. So now I get only this lower uh, 2 bytes, and here we can see we got the exact offsets. So A00 starting and the ending is, so there are so many entries, so you can just check, we get the exact values. So we can call this as string value, and now what we are going to do is we are going to check if the starting character is a or not. If of value of 0 is equals to a, then what we are going to do is we are going to remove the a from this one, because we don't need that a, we want to add only the remaining value. So we can do that using value dot remove. So we are going to remove the starting index and the length. So how many number of characters you want to remove from this starting address, starting index. So from 0 index, that is a, I want to remove 1 character, so the a will be removed. So I can call this as string page RVA. So I can go and print this page RVA. So we get the only the exact offsets without a. So let's convert this into the bytes. So let's call this as byte RVA, and we need to convert this into 64-bit integer. So we can do that using convert.to into 64. So we are going to provide the 16 as a we'll treat as a hexadecimal and convert this into integer. So I think we got the offset. So now the offset only points to the values without a. So all we need to do is we need to add this to the first base dot page RVA. So first base dot page RVA plus offset. So this gives you the offset from the image base address, which contains the value that needs to be updated. So 22,000 plus plus 000, that is this one. So you need to read the 8 bytes and add the delta to this. In the similar way, the second offset is A008. So that means 8 bytes from the page RVA, that is 22008. So if you go to this, these 8 bytes needs to be updated to the added to the delta. So we can also add base address. to modify PTR. So we have finally the pointer pointing to the exact address. So first let us read marshal dot read int 64. So read the 8 bytes. At the address modify PTR. So let's call this as previous value, and this previous value, the delta should be added to this previous value. So let's go and find the delta. So int PTR delta. So base address dot 2 int 64 minus the preferred base address that is stored at nt header dot optional header dot image base. So we got this delta value. So all you need to do is previous value plus is equals to delta dot 2 int 64. Now we are going to write this one right at the to modify pointer, which is pointing at that first address to be relocated in the value to be written. So we have successfully written this. So before any confirming, let's print out all these values and check by putting a breakpoint. So delta so we are already printing the base address in the previous write statements. So we have the delta. Let's also print the preferred base address nt header dot optional header dot image base dot to string. So we are printing the loaded base address and preferred base address and delta, and also we are going to print this to modify pointer, so we can directly examine the value at that address. So let me put a breakpoint at here and let's run this, and we have memory allocated base address and the preferred base address, and if you go and subtract this, we will get the delta. So let's go and see this. Loaded base address minus preferred base address. So here we can see we got the delta value correct, and the first value that needs to be relocated is at this address. So let's go and check at this, and here we can see 14002 BB10. If you go to this one, you get the exact value. So after adding the delta, so this is the delta, and this value will be added to this 8 bytes. So 14002 BB10. So this value should be we should see here. So let's go and click on next, step into, and here we can see 13F 7DEC BB10. So we have successfully modified all of these values. So if I go and click on continue, and this next 8 bytes will be modified. So you can see this, all of these values are being updated. So that's all for this video. We have successfully updated the base relocations. Now I think we are good to go to load the executable. In the previous video we have already loaded the calculator, so let's load that. So if you go and run this, we should see calculator. Also we can modify this script to load the executable in remote process. So all you need to do is you need to change this marshal.copy to read process memory and write process memory. So that we are going to do in the next video.